Good morning. Good morning, members of BISC Bio-Based Industries Consortium, student teams, 5 finalists, and other teams via YouTube, and friends and families of the student teams. Welcome to the Biosynergize event of BISC. This is an annual event, and today we'll be featuring the BISC, the Bio-Based Student Innovation Final, the European final. This is the second round with 5 finalists. Before we go into that, let me proceed to giving the floor to Matt Kwaadvlieg. Matt Kwaadvlieg is the Vice President Strategic Business Projects at SAPI Europe, and Matt is the chairman of BISC and also of the governing board of the joint undertaking that we have with the European Commission. Matt, the floor is yours.
Well, thank you, Nelo. Good morning to all of you. And I would also like to give you all a warm welcome to this event. Bio-Based Industry Consortium is very pleased that we are able to organize this final challenge to award prize-winning ideas with a prize from BISC to support the interaction between students and industry. It's very important that industry gets an insight in capabilities and competences of students and ideas that are generated by their expert teams. And on the other hand, this is also a way to give exposure to students to the industry to see what industry values and what industry is looking for. This is an international challenge, so a lot of European countries participate, and the number of participants is increasing. And BISC is trying to stimulate this initiative to a fully European-wide system where every country participates with candidates, and by the selection of a professional jury under the lead of Kees de Gooijer, but also via the support and voting of the BISC members to identify the finalists who will get a large money prize at the end of this session. This session today is to give the participants an opportunity to present their project, and for the members of BISC to vote on these proposals to find the final winner. So with this said, I'm very happy that BISC can organize this. We have volunteered and we will continue to do so because this is a very important pillar of the purpose of our organization. And I hope that you all will have an inspiring session today. And I wish all the candidates good luck. And I hope for each of them that they win, but at the end, there will only be one winner. So please start the show. Good luck. Go ahead.
Thank you very much, Matt. If we can then proceed, and this will be the start of the Bio-Based Innovation Student Challenge Europe, BISC-E, as abbreviated. And let me first and quickly start by refreshing the minds of everybody online on why is it that BISC is getting involved in this? What is it that we want to achieve with this? Already, Matt said a few words on this, and I would like to repeat just quickly. And I have a slide to support that. If Marco, if you can put it up. But basically, we have 3 objectives with this event, and that is that. Okay, this is the agenda for today. I think, right, let's go on with this. So as I show here on this very wordy slide, first of all, as Matt also said, that we would like to work towards raising awareness or helping to raise awareness of students and involve students in the transition towards a bioeconomy. And we hope in this process that the students will come up with good ideas to help us develop bio-based production processes that can be integrated into current or new value systems that we are developing and setting up. And it will be good if some of these, or if not all, but not some of these projects will focus on real-time issues, things that really play in today's world or in the short time to come. The other objective for us is to work towards integrating the graduating students and into industry and vice versa. So increases interaction. And the participants students are, as shown, these are final year students at the universities of applied science and master students at research universities. We, as third objective, by the two previous objectives, we really are working towards making BISC-E the competition for students in the fields of bio-based education and bio-based disciplines in Europe. And the process that we follow is, as the number continued to increase, we came from 5 and 6 to this year 14, when going into the final straight, 2 dropping out at the last minute, so 12 went to the first round, and next year I'll show you at the end how much we're looking for, but this number is increasing. We may end up in different starting rounds, but this year we had 2 rounds. All teams presented their projects in front of an expert jury, and I'll show you in a minute who these persons were. And the jury, through a thorough Q&A, decided who is and what is the ranking order of these students. And the top 5 were therefore promoted to this final round today. The second round will be that the top 5 teams will present their project now in front of industry. The audience listening to you today will be industries, actors in the field of bio-based across Europe, and they will be co-deciding who will be the winner for today. We have an extensive prize package for the winners, including 1 year complimentary big membership for the student team and for the hosting university, and we will support the team throughout the track towards their future. On the next slide, I think, Mark, can you put it up for me? Yes. Let me show you who are the panelists of this year, the experts of this year, and those who were there last year may recognize only one. The first name, Kees de Hooyer, from the Netherlands. He's a chairman of TKI Agri and Food and the TKI BBE, bio-based economy, in Wageningen in the Netherlands. And Kees is also the chairman. He has been the chairman for this event in the jury for the last 3 years also. Then we have 4 new names. First, we shown here is Marcus Dettenhofer for the Czech Republic. Marcus is a consultant with the BioEast Hub in Czech Republic, and has been very active also in this field and very committed to BIC. The third person on the list is Lenny Lange from Denmark. Lenny is Director of Bioeconomy Research and Advisory. Lenny is a very active member of the Scientific Committee, also one of the advisory bodies of the BBI Joint Undertaking. The fourth name on the list is Georg Lenzen from Germany. He's from the CLIP, Cluster Industrial Biotechnology in Düsseldorf, but he is also the CEO or the director in B-Value AG in Dortmund. And the final name on the list is Astrida McKinney. If I pronounce her name correctly, undoubtedly it's not full correctly, but she's from Lithuania. I know Astrida is a very active person in the region of Kaunas. She's the Chancellor of Agriculture Academy at the Vytautas Magnus University in that city. Again, I would like to thank you all for participating and spending a full day listening to 12 presentations, going to a caucus with yourself and deciding on the 5 top teams. And therefore, you are making a huge contribution to making BISC-E a success. On the next slide, who are the 5 teams? We have shared this information all over the world, actually, at least across Europe. Belgium, the LOF team, converting bread losses to packaging peanuts. This is my words to put it all together from Hoger Onderwijsinstelling in Ghent. This is university level in Ghent, Belgium, Ireland. Phyto Towel, soaking nutrients from wastewater and convert into biomass feedstock for multiple applications. They are from the University College in Dublin. The third team will be BMost, and their objective for the project is to from molasses to a natural soil soap from Università dell'Istudio di Milano Bicocca. The Netherlands, from the Technical University Delft, I know that very well, extracting a novel material from wastewater and turn it into something you can wear every day. And the last team, at least alphabetically ordered, is Portugal, Ecolution, turning peach kernel into high-value product for use as a safe supplement in diets, University of Aveiro. You have prepared a video, each team, and the cases, and everything you can find in our member area, but also on the big YouTube page. Now, In the judging criteria that the judges use and the members of BIC will also be using are shown here. These are 5 and they have equal weight in the judges criteria, and also for you, well, it's up to you to evaluate and give a weight that you want. But first of all, innovation, the innovative aspects of the innovation, the novelty, creativity, sustainability and circularity are very huge on our list as well. How the project contribute to environmental and safe biodiversity, and how is the end of life. Thirdly, technical feasibility. Is it feasible? Can we do it? And scale it up to market. The fourth one is applicability. Is there a market need, and can it be made competitively? And last one, marketability. Look at the whole project, but also, is it well presented? Is it convincing enough? Is it also looking into the future? So these criteria we will put up again when we go into the voting after the presentation of the team, and the steps in the voting are shown here. You will have 2 minutes to cast your vote. Each member of BIC can cast only 1 vote. As soon as you cast the vote, it's gone. Students and members of the panel of experts are not allowed to vote. They know that, and we will keep track of that. Having said that, I'm ready to turn to the first team. The first team will be Belgium, and speaking for Belgium to start with will be Marthe van der Broeke. Marthe, please go ahead.
Okay, we are LOFO, and we are 5 biochemistry students from Ghent, from Team Belgium. My name is Marthe, and my colleague Niels will present soon. So we want to be, so there are 2 challenges that LOFO wants to tackle. Did you know that 20 million tons of bread is wasted yearly in the European Union alone? And that there is a production of 1.5 million tons of expanded polystyrene packing peanuts each year worldwide? This contributes to the huge plastic pollution, and this has to be better. So we, LOFO, we have the solution. We want to be the first company that transforms your bread waste into biodegradable, starch-based packing peanuts for your goods. So the first step in our production chain is to dry and grind the bread waste into a bread powder. This step will be totally done by our collaborator Trotec. In the second step, the starch is extracted out of the bread powder, and this is done with a precipitation procedure that was made with the College University of Ghent. In the third step, the actual packing peanuts are made with an extrusion step. And then, of course, the last step is to sell our packing peanuts to a distribution center. So as online shopping is booming and there is more need for sustainable packaging, we contacted web shops, small, large web shops. For example, we had contact with Wondercare, Veritas, Lush, and many, many more. And they showed a big interest in our packing peanuts. Niels, the floor is yours.
Thank you, Marthe. In order to make this all work, we need a capital expense. If my slides are moving, we need a capital expense of 50,000 euros. This capital expense is our precipitation material and is our extrusion material. Our operating costs are an estimated 51 euros per cubic. And that 51 euros, everything is in there: transport, personnel, taxes, because it's Belgium. You say it, it's in there. Our selling price is 125 euros per cubic meter. This is conform to market standards, and our profit is 74 euros estimated per cubic meter. This profit makes a fairly short payback time of 40 days of 4 hours production. And then our environmental impact reduction, we want to do better than EPS. So starch packing peanuts have a 50 to 90% impact reduction on the environment compared to EPS. But for LOFO, that's not enough. We want to do even better than starch. So on the left, you have the standard starch-based packing peanuts like they are sold today. So you have a resource, corn, for example, and this corn is turned 100% in a consumption good, the starch-based packing peanuts. We of Low Foam, we want to do better. We don't want to use a resource that's specifically grown for our product. We want to take a consumption good that's already been offered to the consumer and then take that consumption good, process it with our procedure and make another consumption good out of it. And then insert our waste stream back in the cycle, committing to a circular bioeconomy. So given our procedure, given our innovation, and given our benefits, I hope I and Marta could convince you that Low Foam does take your breath away. Thank you very much.
Thank you very much, Team Belgium. Interesting project and interesting presentation. Before we proceed with the Q&A, just a quick statement from my side. You may have seen, or you have seen on the agenda that Kees Gooijer, the chairman of the jury, was to speak. It was my mistake. I skipped him, but Kees, I know that you will forgive me. We'll give you the floor after all the presentations, okay? All right. The floor is open for questions to the Belgian team. Anybody in the audience? You can raise a question either by raising your hand or type a question in the Q&A or in the chat box.
Okay.
Let me see if there's anything in the chat box or the Q&A.
I don't see the chat box right now. I'm sorry.
Okay.
Okay. I see a first question. I have
There's a question, yes.
I see a hand raised by Mr. Quadfree. Maybe we can answer that question first, if that's possible.
If you see the question, or is Matt going to come in?
I was going to come in. Thank you for the floor. My question was, when you showed the diagram, there was a conversion at this bread collector, and that involved drying and grinding. In your energy figures and your assessment of the environmental impact, is that process step also included, or do you start where you get the raw material?
It's also included. We've been in contact with Trotec, and all the processing they do of their bread is powered by solar energy. They are really committing to this ecological energy needs. That's also included in the steps.
And also, yes, in our cost price, also the transport and the electricity needed is included. So we have calculated in.
Is a follow-up question allowed? If you say it's solar powered and then you discard the energy consumption, that's not really fair, because any other energy conversion could be solar powered. In the comparison, you should take, let's say, the energy used.
Yeah, but we know their energy needs, and we have calculated it in our calculation. Regardless of solar, of not so solar energy.
Okay, that's satisfied. Thank you.
You're welcome. I see another question
in the chat box.
And the question: are the regulatory? What are the regulatory constraints for your product? So we have looked this up. And the regulatory constraints, there aren't so many, because it's not, we don't pose any environmental harm. We are not using toxic chemicals. We are just using starch and water and a plasticizer that's most likely glycerol. So we are not working with any toxic materials. and we are looking into the regulatory constraints right now, but it's a bit difficult to find the answer to that question, because it's difficult. And I see, yes, I see the presentation again.
Okay.
So I see the follow-up question. All bread is often molded, no issue. No, it poses no issue to us. It poses mostly an issue to Trotec because they are selling the bread and using it as a cow feedstock. When the cow feedstock has a too high mycospores count, it cannot be sold. So they have this excess they get rid of anyway if it's too molded. But for our product, it doesn't affect our product at all. So we can take the bread powder and that they don't get that they can't use, and we can use it in our process.
Yes. I see a question in the Q&A.
Yeah,
so they
of course.
ask how
Yes.
the collection of the bread residue. So this is done with the collaborator Trotec. So we don't collect the bread. Trotec does this from industrial bakeries.
Mhm.
So they take the step away from us.
Yeah. They also have given us the option, if we want to go on consumer level, we can also contact them because they are also willing to cooperate with us. But right now, it's from the industrial bakeries because they have a lot of waste of bread.
Next question.
I will.
Okay. Just a moment, Marta.
Yes.
I see we have a number of questions. Let me first take you to the question in the Q&A by Tatiana Schwaber.
Okay.
Can you see it yourself, the question, so that I don't
Yes,
have to
we
read
have
it?
it
You see
open.
it shown in the cartoon? Okay, can you take that question, please? And then I'll go on to the others in the chat box. Go ahead.
So the other question is, will consumers on your consumers be reticent to touch pellets made from such a substance?
Well, the pellets are heated in an extruder to temperatures of several hundreds of degrees. So they are completely sterile when they come out. Yeah. There's no mold. You can't see mold. There's no harm to it. And in our presentation, we've a little bit exaggerated it with the mold because we really wanted to show we can use moldy bread, but when it is dried and when it is processed, it's already as good as sterile because it needs to be fed to livestock.
Is there any, Patricia, do you see any other open questions in the chat box or the Q&A that we have not dealt with? Okay. Let me ask you in the meantime one question, Team Belgium. Do you have support of local or regional or national policymakers, governments? Have you shared this idea also with the local policymakers and even parliament or politicians?
So what we have done, we have made our product, we are developing it with the student business incubator at our university college. We're getting a lot of guidance from the University of Ghent. And it's together with them, we are developing this, make our idea better. And we even, we do a lot of publicity. In fact, we have done podcasts, we have been in newspapers, etc. We really want to get our idea out, but we really want to fund it or to found it, better speaking. So we get a lot of support from our schools, but we want to take the next step and are open to join any. In Belgium, we have a lot. We want to join any sorts of student business competitions. So we are really looking for guidance.
Yeah.
Okay. Let me put you a question by Nuno Coelho from Portugal. Nuno, you raised your hand. Go ahead, please.
So questions about the CAPEX and the OPEX. Could we have some detailed numbers?
Yes. So we have everything calculated. So the operating cost exists of the machine electricity that we need. This comes on a total of 2.94 euros per cubic meter. Then we also have the bread powder that we buy from Trotec, of course, and they have a price of 25 cents per kilograms, which would be a total of 19 euros per cubic meter. Then, of course, the transportation from the bread powder from Trotec to our location would be a total of 1.3 euros per cubic meter of production. Then we also included our salary. So if we assume that we have two employees, it would be a total of 12.9 euros per cubic meter. Then we also included the insurance and then also the heating of the offices and all the other small things. So this comes at a total operating cost of 51 euros per cubic meter. And then our capital expenses exist of our extruder, which is our biggest cost. Then, of course, we need our mixing recipients and we need our settling tanks. And this was estimated on a total of 50,000 euros. So then with these numbers, we could calculate our payback model. So when we sell our packing peanuts at 125 euros per cubic, which is actually a 10% lower than the market price. So then we had a profit of 74 per cubic meters. And when we estimated that we could produce 17 cubic meters per day, then we would have a payback time of 40 days.
Okay, let me take, we have one more minute. I would like to take up this question by Serge Kreutz that you can see in Q&A if you open it. Is there today already use of the bread waste?
No, in Belgium there isn't. It's only cow feed. The bread is only used as cow feed. There are local alternatives. We have a huge supermarket. It's called the Koren. It's in Belgium. They are using bread to grow mushrooms on it, but it's only their own bread. In Belgium, there's not a huge economy of this bread. It's solely used as cow feed. So we are not competing. We are taking the product off their hands. They can't use for cow feed. Now it is directly delivered to biogas stations, and they want to minimize this number because it's not really profitable for them too. So no, we are not competing. There's a steady in-stream of waste material. We are not competing with any alternative today.
Okay, excellent. Thank you very much, Gijs and Marta, for answering these questions. I'm pleased to see, and I hope you're too, as all students in the streams to come, that as you can see, big members are all into this, very involved, and we would like to ask you a lot of questions because we would like to get a better and firm idea of the project so that we can cast a good vote. All right. So thank you very much.
Thank you.
Belgium.
Thank you very much.
And then I would like to proceed to the second team on the list, and that will be Ireland. And speaking for Ireland will be Laura. Laura, you can take the floor.
Okay. Hello, everyone. We are Phyto Towel, and we are here today to represent Ireland. Water is life. As an island nation, we are really proud of our beautiful coastlines, our clean swimming water, and all the aquatic life supported by it. Unfortunately, images like this are too common. Eutrophication can be caused by misuse of chemical fertilizers and the improper disposal of nutrient-rich wastewater, which has catastrophic impacts on our aquatic ecosystems. Luckily, we have developed a technology to solve this problem using a towel. So what do I mean when I refer to a towel? What I'm talking about is the Phyto Towel. It's an innovative, bio-based water cleaning technology using duckweed. Inspired by nature, we took the process of phytoremediation, which simply means a plant's ability to uptake nutrients from its environment and convert it into valuable biomass. We designed the Phyto Towel on this basis. It is a mobile, modular, scalable solution that is flexible for our customers. When looking at an industry to target with our innovation, we looked at a very polluting industry, the dairy industry. It's a huge industry, producing up to 1.66 trillion tons of wastewater every year in Europe. For every 1 litre of milk produced, up to 10 litres of wastewater is produced. This wastewater, however, is ideal for valorization. It's high in nutrients like nitrogen and phosphorus and does not contain any toxins. Let's have a closer look at the technology. How does it work? On the left, you can see a top-down image of our design, the Phyto Towel. Wastewater enters the tank, which contains 10 layers of duckweed, which act like a towel, soaking up the nutrients. Clean water for reuse exits the tank, and the duckweed is harvested automatically. We have designed the Phyto Towel in this way because we want to be able to scale our product with our customers' growing needs. Okay, so what makes us different to what is already out there? Conventional wastewater treatment is energy and resource intensive. It also produces further waste products called sludge, which then have to be destroyed as well. On the other hand, the Phyto Towel, sorry, there's a bit of a lag. The Phyto Towel is a bio-based solution and it doesn't require any additional chemicals to work. In fact, it actually replaces chemicals in the wastewater treatment system. It's a circular zero waste process, and the products that we produce from the Phyto Towel go on to close this loop and reused on the farms themselves. We are going to disrupt the market in 2 ways. The first is through the production of animal feed. So this is a high protein animal feed that replaces environmentally destructive products like soy, which Europe is heavily reliant on importing every year. The duckweed product that we will make to replace this is high in protein and highly nutritious, and it doesn't require any other resources from Earth to make. In fact, we can grow it on wastewater. The other product that we're going to make is a phosphate-rich organic fertilizer. This will replace unsustainable fertilizers like chemical fertilizers and peat-based fertilizers. This fertilizer actually gives back to our soil instead of taking away from it. So I know what you're thinking, this is a great idea, but is it actually going to work as a business? So our capital costs are, you could say they're relatively high. They come in at just under €5,000 per tank. However, our operational costs are low due to our innovative design. We also have 2 business revenue streams. The first one comes from the subscription service that the farmer pays or the waste processor pays on a monthly or annual basis for the purpose of cleaning their water. The other revenue stream comes from the products that we're going to make, such as the animal feed and the fertilizer. These products are going to increase in value over time, making the Phyto Towel a profitable business by year 4, in the early months of year 4. As these products gain more interest from our customers, we believe that the Phyto Towel will grow along with them. So for example, sorry, the slides have gone on. As an example, the organic fertilizer market has a compound annual growth rate of 14%. And as demand for such products increases over time, we believe our business will grow alongside it. So what are we going to do next? Take over the world? Well, first we need to secure some funding and build our first prototype at our pilot operation here in Ireland. We're then going to go on and build a market presence through gaining organic certification for our products and learning how to market them correctly. We also want to get involved with some incubators like Hatch, which we've already been in discussion with here in Ireland. And then we'll go on to expand our team, making some key hires and exploring the higher value product pathways, such as omega-3 extracts, which have a really high value and can bring the Phyto Towel along really well in the business, and also the human food market. We would then like to expand our product across Europe. So we're really looking forward to bringing our water cleaning solution to other countries and helping to keep our water clean for all the aquatic life it supports. Water is life, let's fight for it. Thank you very much for listening.
Thank you very much, Laura, for this presentation. Phyto Towel. And now, again, time for questions from the members. And I will take a look at who's coming in. Any big member, please either raise your hand or pose a question in the Q&A or in the chat box. I see a first question coming up from Ed de Jong in the Netherlands. How do you keep the duckweed free from contaminations? Laura?
Thanks for the question, Catherine. So we also have a solution, a preserving solution. It's made up of citric acid and salt. So when the duckweed is harvested from the tank, it can go into a holding chamber, which contains this preserving agent. It's a natural food grade preserving agent. So the duckweed can stay in there until we come to collect it.
All right. Ed, I think this will be doing for now. I will now move on to Nuno Coelho. Nuno in Portugal.
Can you listen to me?
You raise your hand. Yeah, go ahead.
Can you listen to me?
Yes, we hear you. Go ahead.
Okay, thank you. Thank you very much for this nice presentation. I have two things I would like to emphasize. First thing, I would strongly recommend that beside duckweed, you also look at algae, namely microalgae. But the point is, the quality of your final product will highly be dependent on the quality of the water stream that you want to treat. And for me, that's a big issue that will probably won't allow you to produce animal feed from any waste stream. I would like to hear your comments on this. Thank you.
Yeah, just the reason that we targeted the dairy industry in particular is because, at least in Ireland, there's a point where you're processing the dairy, and then before it is labeled as wastewater, it is still labeled as a food byproduct. And so in that way, it's the perfect source of valorization, because in terms of marketing, we can still use it as feed or even as food, because that's how the legislation is, at least in Ireland.
Okay, thank you for that question. For now, I would like to get as many as possible questions in. Next one is Irina. Irina Villalieva in Spain. You raise your hand, Irina, go ahead. Irina, either she's muted or not.
I also, just realized I forgot the first part of the question.
Go
no, sorry, I couldn't find how to deactivate the silent. So
okay, wait. This is Irina. Yeah, go ahead, Irina.
Can you hear me now? Yes.
Yes, go ahead, Irina.
Yeah, it's just I have questions regarding your the technology protection, because you haven't mentioned that how it's in terms of innovation, there is possibility of patenting, or how you will protect that, because it's really it's from technological point of view, it's not difficult to build and not very costly, as you mentioned. That's one of the advantage. So how you will protect your technology from competition?
The Phyto Towel is different from other systems that are already out there because we're offering something that's scalable. So we have 10 layers of duckweed inside our tank. And because of this, we can be accessible by small dairy producers as well as large dairy producers. So the smaller company can still be involved with the Phyto Towel and use, let's say, 3 layers of duckweed as per their requirements. And then as their business grows, the Phyto Towel can grow along with them. So from what we've seen on our market analysis, this is the most unique aspect to the Phyto Towel. And this is probably something that we would look at getting some IP on.
All right, good. Thank you for asking also, Irina. Let me move on to Bruno, Bruno Ferreira in Portugal. You can see the question in the Q&A box.
Yeah.
Can you take a look at it, please, Laura?
So Bruno said, given the large volumes of waste to be treated, how many containers would need?
Right. And how would you compare your solution with microalgal-based systems, and how would you prevent microalgae to grow in your cultivation system? How about that?
Okay, so we based our initial design on a medium-sized dairy producer. So we have the figures there for how much this is. 1,400 kilograms of wastewater per day can be cleaned based on the current design at the 10 layers full capacity. So this would suit a medium-sized dairy producer. And then on top of it being scalable on the inside, we can simply add more containers to the farm as it's needed. So we can double up capacity really quickly if the farmer needs us to.
Yeah.
And that's it, yeah.
Yeah, I can go with the microalgae one.
Yeah.
Yeah, I wanted to say that when we started our project, we looked at multiple aquatic biomass. So like microalgae, macroalgae, duckweed, and some other aquatic plants. And in the end, we decided on duckweed as opposed to microalgae because it's much easier to harvest and to process. Microalgae, as some of you may know, requires a lot of downstream processing in order to separate it from the water. And with duckweed, it grows on the top of the water and it's very simple to harvest. And we could even do our automated harvesting system quite simply.
Okay, thank you for that. Let me pose you the question by Rob Bakers in the Netherlands. You can see it also there in the Q&A. The idea is very specific to wastewater streams at a dairy production location. Have you pitched your idea with a leading dairy producer? What was their feedback, and are they keen to invest in the solution? Please.
So we pitched it to a company called Arabon. They're a really large dairy producer in Ireland. They were very helpful, and we asked the main guy there himself if he would be interested in something like this, a solution like this. They already have a very complex wastewater treatment solution, and he pointed us to the need to replace some of the chemicals that they currently use. They use something called ferric sulfate to remove phosphate at the moment, and he was really interested that the Phyto Towel could actually replace this step, and they're always looking for greener ways to clean their wastewater. So he thought the Phyto Towel was a really good idea and was very excited to hear how we got on.
Excellent. We have to leave it at here at this point, Laura, and your teammate in Ireland. We have consumed all the time many questions, good questions, I think, good questions by the big members. We will collect, as a matter of fact, other questions that we have seen and not been answered throughout the process, and we will put them forward as needed and required. Thank you again.
Thank you very much.
Okay, we would like to move on to Italy. And speaking for Italy will be Vittorio. Vittorio, the floor is yours.
Thank you. Good morning. So we are Team BIMOS from Italy, and it's a pleasure to be here today. Climate crisis awareness is pushing governments towards actions against fossil fuels and greenhouse gases emissions. But the problem is not only in what stands above us, because an issue of the same size is hidden just underneath our feet. We are destroying and polluting our planet day after day without even noticing. Petroleum-derived molecules from industries, transportation, and agriculture are threatening the only surface that can sustain life, the soil of our own planet. And we can dig further down. The problem of soil pollution isn't only on the surface, its roots go deeper. The contamination doesn't only affect what we can see, but also everything underground. This is why we must care. This problem affects us all. We need to stop polluting our environment and start addressing the issue of remediation. But how is it possible that no one has already thought this through? Well, up to now, we tried and struggled to clean the soil with products which come from the very same source of the pollutant themselves, petroleum. Their production is not sustainable, and the clean soil, well, remains polluted by the traces of these molecules. It doesn't seem like a good deal, does it? So what we offer is a real, sustainable, and natural solution, soil soap. We developed a process to produce a molecule which scientists call sulfurlipid that nature has been using for millennia to clean itself. But we want to produce it on a large scale, large enough to address the terrifying magnitude of the contamination we caused. This cleaning process can be green from the beginning to the end. Our process is not a traditional chemical synthesis in which petroleum-derived raw materials are converted into the desired product and a bunch of byproducts that are hard to deal with. We came up with a complete bioprocess based on a combination of two yeasts, two minuscule microorganisms that, when combined, are able to convert a residue into a natural soap for the soil. This clever combination is our biggest innovation, but let me explain. Nature gave us a wonderful little yeast that is able to produce our natural soap by eating sugars and oils, two ingredients we all know well. But what you may not know is that we have plenty of sugary residues, molasses, from the sugar industries, which is rich in nutrient and perfect for our process. By exploiting it, our idea can really be sustainable. However, the need of the precious vegetable oil has prevented industries from using this wonderful yeast. And that's where our real innovation comes in. Our soap producing yeast is helped by another little yeast that is able to convert cheap molasses into the otherwise expensive oil in a natural and sustainable way. And it's done. A cheap feedstock, a clever combination of microorganisms, and a natural soap for the soil. That's circular bioeconomy. We're also working towards responsible consumption and production to protect and restore life on land. And we also reached the zero waste goal, which translates in a very low environmental impact because every byproduct is valuable. A yeasty feed enriched in useful nutrients for the animals and profitable small molecules, such as carotenoids, kindly produced by our yeasts. We produce very small amounts of CO2 and the water we use is recirculated. We are confident that our process can be a success because a computer simulation of the plant with a professional software proves that our idea is feasible and scalable. So we are partnering with a biotech company, Clever Bioscience, to develop a pilot scale plant. The next step is to bring our process to an industrial scale to reach our aim of an inexpensive solution for soil pollution. We want a fermentation company to invest in soil soap so that our product can be available for bioremediation. Our solution must reach the soil before it's too late. So join us in the production of soil soap. Let's create together a natural solution for soil pollution so that we can sit together on a clean soil. Thank you for your attention.
Thank you very much, Vittorio, for Italy, the most soil soap proposal. Thank you very much. I'm looking immediately for questions from BIC members present. Any questions? Let me see the Q&A. I believe we have a question here from Hendrik Wageman in Belgium. In the Q&A, why would you not use a waste oil, for example, waste cooking oil, instead of synthesizing it?
Okay, thank you for the question. We researched about this topic and we decided to produce our own oil because to be consistent during the process and to keep the input streams as small and as reduced as possible. And another problem we found is that the waste cooking oil is more difficult to standardize because of its variety and even the collection of the oil would have been too expensive to reach a commercially viable product. Instead, our own produced oil is sustainable, and we have only one source from which we start the process. So we are confident that this strategy is better than using a waste oil.
Okay. You know, as you see, my strategy is in order to get as many questions on and you maximum opportunity answer, unless there is a follow-up question by the questioner, I will proceed immediately, and the members listening to your question will judge you on the answers. Let me proceed with the question by Tatiana in Germany. What will be the target market for soil soap?
So our target market will be companies that are already involved in the cleaning of the soils, which are at the moment using the chemical counterparts for our as surfactants. So our idea is to sell our products, which is more environmentally friendly, not only from the actual biodegradability point of view, but also from the process of making it. And we can also, our idea is we can also have a more purified product, so we can later expand our market towards more niche sectors, for instance, in the health or in surfactants used in households, which could be that could be the future.
Okay. I will proceed with a question by Emma Nemet. What would be production costs and how it compares to traditional soap production costs?
So the production cost would be, let me take the data, sorry. So first off, for the comparison, it's a little bit harder because we should compare it with not soap, because soap is generally used for personal hygiene or in industries, but we're using a non-purified product for the moment, and it's more of surfactants for the environment. So anyway, the production cost would be this one. $28,000 per kilo. No, $28 per kilogram of our product.
And we have a revenue of $45 per kilo of the product. So we have a positive economic balance, and this estimation are a low estimation of what we can do, because the production cost is considers every cost of the plant, from the design to the scale up of the plant, and instead the production revenue doesn't consider additional revenues from other byproducts, and we produce at $28 per kilo, and within the simulation we aim to sell at $45 per kilo, but we can enhance the revenue by selling other byproducts we are not considering for just for simplicity. And another factor that we are considering in the production cost are salaries and every other cost for the plant, and the economic balance can be further enhanced, and our feasibility is eased by the expansion of the market of surfactants that will make it easier to build and make revenues from the production of soil soap.
Okay, thank you. I hope my friends Nuno, Rob, Bruno, Irina, and Hendrik don't mind if I skip on to a question from a new poser, a question, Mahmoud. Mahmoud, question also in the Q&A, you can see it. Soliance is part of Givaudan, is commercializing sulfurolipids as antimicrobial surfactants. Is there any difference between your products and the ones out on the market? please.
So the class of molecules is the same, and obviously every strain and operating condition will produce a different mixture and combination of different forms of saccharolipids. The product itself is the same. What's different is probably the grade of purity, and our actual innovation is not on the product itself, but it's on the process by which we make it and the use we want to make it.
We wait for.
Should we move to the next question, or?
Sorry, I was muted. I would like to put forward to you the question by Bruno Ferreira in Portugal. Do you need to purify the oil before it's taken up by the second yeast?
No, and that's actually an advantage, because not only we get oil from the previous biomass, but we also get all more nutrients that will allow us to reach higher titers of biomass with the next yeast. It's basically a yeast extract, which is a common reagent used in industries for yeast biomass expansion. So that's actually an even more positive input into the next fermenter.
Okay, thank you. Let me ask you probably a final question, because the time is running. Have you contacted local, regional, national governments, policymakers, etc., and get their ideas, support, whatever?
Unfortunately, not. Unfortunately, not yet. But we want to do that in the future. To see how these go.
Okay, that's it then for Italy. Thank you very much, gentlemen.
Thank you.
Thank you.
All right. We then would like to move on as planned with the next team up, and then will be the Netherlands, Water Skins, and speaking on the project will be Gijs. Gijs, the floor is yours.
Thank you very much. We are Gijs, Maaike, and Casper from the Netherlands. And we believe that life starts with clean water and that everyone should have access to it. Unfortunately, this is far I'm very sorry, I was muted and I have to go back.
Yes, Gijs, if you hear me,
yes.
Can you restart, because we lost you? Please restart.
Yeah, I'm trying to get back to this. Yeah. So thank you.
Thank you.
Reset. We are Gijs, Maaike, and Casper from Team Netherlands, and we believe that life starts with clean water and that everyone should have access to it. Unfortunately, this is far from the case, as over 2 billion people do not have access to clean drinking water. Largely the result of the more than 5 billion people not connected to a sewage treatment facility. Together with the untreated discharge of heavy industry, the pollutants and pathogens that are spread cause the tragic death of 3.5 million people annually. Our mission is to help solve this crisis, and we propose a solution on 2 fronts. First, by preventing pollution by competing with the heavily polluting leather industry. And second, by incentivizing investment into wastewater infrastructure by valorizing wastewater treatments. Introducing Water Skins, the leather that's developed to help clean our waters. Water Skins is produced using a promising new resource called Comera. Comera is a biopolymer that is extracted from wastewater during the cleaning process. It consists mainly of glycoproteins, which is the same major constituent as in real leather. To this Comera, we add biodegradable additives and we process it into 100% biodegradable and animal-free leather. By using Chimera, we add a revenue stream to the otherwise expensive process of wastewater treatment. And what's more, by reducing the sludge that has to be disposed of, we directly reduce operational expenditure. We can achieve all this at a competitive price. The production of our prototype material is calculated to be €6 per square meters. Competitors in the vegan leather market sell their product at €40 per square meter, so we have a large margin to work with. Our prototype material has achieved a tensile strength of 5 megapascals. This figure is highly dependent on processing steps, and we can dramatically improve this 5 to 10-fold by using the proper processing equipment. The Young's modulus is a measure of suppleness. We estimate this to lie between 50 and 500 megapascals, roughly the same range as leather. And finally, our product is naturally flame retardant, making it ideal for use in sectors as the aviation, where fire is a serious hazard. We have some key advantages over our competitors. First and foremost is the sourcing of our raw material. Chimera is produced centrally and on a large scale. Each wastewater treatment facility processes the effluent of a given number of people, and each person produces a certain amount of Chimera per year. This makes the production abundant, reliable, and consistent. The production process we've developed is not that complicated. We mix in our additives, we dry it, and we cure it. Finally, on a fundamental level, we can achieve a higher similarity to real leather than our competitors that use cellulose fibers or polyurethane by using glycoprotein. We've showed you the material properties and a bit of the production process, but we've started with the problem of water pollution, and we said that we would help solve this problem. We do so by lowering the cost of wastewater treatment plants. These plants are normally very costly to operate, causing a large part of the world's large number of communities cannot afford it. We add a revenue stream by buying Chimera, and we reduce operational expenditure by lowering sludge disposal. Second, we prevent pollution. Our life cycle analysis shows that compared to the leather tanning process, human toxicity potential is reduced 54%, and global warming potential 75%. What's more, because we actually remove nutrients from wastewater and prevent it from ending up in the environment, we can achieve a net positive acidification potential and freshwater eutrophication potential. To conclude, we have developed a vegan leather alternative that's 100% biodegradable and animal friendly at a competitive price while helping to clean our waters. We were Team Waterskins, working towards a cleaner future, and we would like to open the floor for questions.
Yeah, thank you, Gijs. Sorry about that. There was a quick or very short crash. Can you move back, if you still have control, to the previous slide, just to give you all fair treatment? Before this conclusion slide, do you have control?
Yes, I think so. This one?
All right. Yes. Did you finish on this one?
I finished on this one.
Right. Okay, I think you covered all these points. Yes. Okay, can you move back to the final slide? I'm sorry about this, but I just want to give all teams a fair treatment. Okay, you made your points in the conclusions, correct?
Yes.
Excellent. Thank you very much, Gijs. And I would like, thank you, quick, nice picture of your team there. And the floor is open to big members. Please, go ahead. I see in the chat box. Nothing yet. Well, while big members are looking, I have a question for you. You mentioned that the leather would be a very attractive alternative for the aviation industry. So my obvious question is, have you had contact with the aviation industry, and what is their response or reaction?
We have not contacted the aviation industry in particular. This is just a property of our material that would make it relevant for use in sectors where fire is a hazard. We have contacted Eco Leather, which is one of the largest producers of leather, and we've pitched our idea to them, and they were interested in to collaborate in developing this our product further, and they've opened their lab and their equipment to us.
Okay, thank you. Let me see if there is a question, and there is a question in the Q&A. If you can open the Q&A, you see what I'm going to read to you. What is the competitive advantage of your technology compared to Comera Nereda gum, already in industrial production in the Netherlands? I presume you know what this is all about?
Yes, if I understand your answer correctly, I can answer it in this way. We actually use Comera Nereda gum. So the material is currently in pilot scale production and has the potential to be produced at a very large scale, this biopolymer Comera Nereda gum. The problem is that there isn't yet a market for the product. So we are creating a market for a product made from the material to create demand for the Comera. I hope this answers your question, and I hope that I got the question right.
Irina, I think you did. She doesn't have a follow-up question. Let me see if there is anything in the chat box. There is a question by Dirk Carré of BISC. What is the possible market for this kind of bio-based leather? You mentioned a few, but maybe you would like to expand a little bit on this.
I think Micah can answer this question.
Micah.
Yes, thank you. I'm now looking up the numbers, but we have noticed that the vegan market, so the market for people who want to wear vegan leather, is increasing, and a lot of people are becoming more and more aware that they want to wear something which is not hurting the environment, first of all, and which is not hurting animals. So I hope that answers your question. I can look up the numbers if you really want to know these.
Maybe I have a follow-up question that, listening to you, when approaching market actors, in particular citizens, consumers, and trying to get them to, or convince them to take over something to wear on their body, and if they would know the origin, sludge, wastewater, etc., does this present any issue? Have you had any feedback on that?
Well, we currently, it is of course a big issue for people if you say, well, you're wearing something which you flush down your toilets, but this is not actually the right way to represent our material. The material is based from bacteria which clean the water, and this is maybe also not the best thing to really sell. So, but it is something which would happen in the future. Already at the Dutch Design Weeks, now houses are built using fungi and bacteria. So this is something that we will have to look into in the future to also use these kind of resources. And of course, we would need to do some branding, and that is why we're planning to work together with a lot of high fashion industries brands to make sure that that people are not afraid to wear our material, because it will be completely safe for them to wear, and it needs to get a slightly different vibe to it. I hope that answers the question.
Yeah, yes, you did to me. You're out to get cooperation, partnership with actors, the right actors in the field, and sell the benefits, which is the right track. Yes.
To add to that, maybe we would definitely focus more on the circularity aspects and the renewability of our product. And taking a page out of the book of our competitors, such as Milo of MycoWorks and Deserto and Pinatex, they have been partnering with known brands. So this is something that is done, and I think that there are a lot of brands that are looking for a way to attract eco-conscious and vegan consumers as well.
Excellent, thank you. Many questions coming up. I think this is an interesting subject. If you also take a look at the Q&A, I would like to take up the question by Oscar, the first one that I see. Interesting material. What is the availability of this material? Which volumes are already now available for maybe further testing or would be available, please?
Very good question. As I mentioned, this product is currently being produced at pilot scale, and there are 2 pilot facilities producing it, and 2 more in process of being built. When the pilot scale has been completed, the potential is actually quite big. So we've calculated that only based on municipal wastewater, the theoretical supply of Chimera is enough to supply the world's leather market 4 times over with our material. And then you can add the wastewater from industry, which can also be treated using Nereda wastewater treatment facilities and from which Chimera can be extracted. So the theoretical production of this material is definitely not limited. The only thing is that at the moment, it's at pilot scale. As soon as this is finished, it will definitely roll out. And if there's a market for the product, which we are creating, Chimera product, which we are creating. Yeah.
Thank you. While I'm looking at other questions, there's some interesting questions. Let me quickly ask you this question. Have you had contact with wastewater management operators, with the local governments, with the national governments on this project, this idea that you have?
Well, we are, of course, in contact with the TU Delft, and the TU Delft are one of the partners who helped to develop the Chimera process. So we have had a lot of discussions with some of the professors there, and they are very positive about our idea as well.
Positive. Okay, thank you. Let me ask you, I'm jumping a little bit forward, many questions. Thank you again, big members, for this. Let me take up the question by Tatiana. Do I understand correctly that your technological innovation is the additives that you add to the Chimera to produce the bioleather? Is the production of Chimera already established by another company?
This is indeed true. Our process starts at the moment that we buy the Chimera from the wastewater treatment plants, they would be able to produce this. And then we mix in our chemicals and make an alternative for leather from this material.
Can I just slightly nuance that? Because I think that our technological innovation is more the idea to use this product as a leather. So it's not necessarily the part of the additives, it's just the use of this glycoprotein material and process it into something that is more similar to leather than other leather alternatives. And yes, for that we have to add in some additives.
Well, maybe this relates. A question by Bruno Ferreira. What is your freedom to operate? Not owning an IP on Chimera process, rather having developed a rather interesting application development from the pre-existing product. Can you independently sell the product? Do you need a license from Chimera, etc.?
So, as mentioned by Maaike, we have developed this product as part of the group that has actually developed the production process of Chimera as well. And every stakeholder in the Chimera process is very eager to find applications for this product. So I definitely do not believe that this is going to be a product. So currently there are some niche applications for the material, but as mentioned before, the production capacity is huge and the large scale applications are not yet available. So that is where we would come in.
All right. Ladies and gentlemen, Maaike and Gijs, thank you very much for your responses to the questions and the presentation, of course. And we are running out of time for your block and we are going to proceed. Thank you again.
Thank you.
Now on to the fifth and the last presentation by Portugal, Ecolution, and to introduce the project from the University of Aveiro is Tanya. Tanya, the floor is yours.
Thank you very much. Good morning, everyone. First of all, we would like to greet the big jury member and the community present here. We are Ecolution, and today we bring you an ecologic solution. So, did you know that Portugal produces about 1.3 million tons of fresh fruit each year? Yeah, and it tends to increase. Getting more specific, according to the last national statistics, 47,000 tons of peaches are produced here. Of course, a large number of these are destined for the direct selling market to consumers, but the remaining are used by food transformation industries. And if you stop to think about all the food waste we generate every day individually, consider this proportion at an industrial level. You can imagine the tons and tons of kernels and peels that are simply discarded every day through incineration. and that's a big problem that should concern us all. But what if we transform peach kernel into conjugated linoleic acid, CLA? Why this product? It's a high value-added compound due to its anti-carcinogenic properties and application as a growth factor, and also as a human body fat mass decreasing supplement. But now let's get a little bit more technical. So, starting with our peach kernel, we would obtain this raw material in compound, a crucial partnership for the development of this idea. After milling the peach kernel through a supercritic fluid extraction, we will extract the lipid fraction from the flour and subsequently isolating the linoleic acid. Afterwards, in order to biotransform this linoleic acid into CLA, we will use the Lactobacillus plantarum under microaerobic conditions. Lastly, the microorganisms will be separated and harvested by centrifugation, and CLA separation, quantification, and purification will be performed by HPLC. Although not perfect, we are certain that these steps are the crucial and the most adequate for the process. The literature reported conversion yields, we hope to obtain for every kilo of peach kernel 57.6 grams of linoleic acid that will be therefore bioconverted into 49.1 grams of CLA. But you might be thinking, with all this equipment and reagents required, is this still an environmentally friendly process? If you take another look of our process, we obtain CLA and some wastes. On one hand, there is CO2, which recyclates back to the input stream, and on the other hand, there are 3 residual streams, totally composed by harmless compounds. Within these, the unused kernel biomolecules present potential for further reuse. So, because we want to ensure a full circular economy, we propose here several potential destinations for the proteins, fibers, and lipids unused, adding not only sustainability, but also rentability to our process. Besides this, in comparison to chemical synthesis, our microbial approach gained relevancy, avoiding potential contaminations and low purity rates of the product. They are typical to the conventional process. But now you may be asking if it is economically viable. You know, without money, we can't go anywhere. But the global market for CLA is characterized with a compound annual growth rate of 6%, proving to be an increasing market full of opportunities and enough room for our idea and for the competitors. Overall, we expect a 2.46 euros per kilo of peach kernel that can surpass all the costs associated with the process. But as all innovative ideas implemented in the food and drug industry, there are some initial weaknesses and threats, such as the long R&D production times or the strict regulatory product approval. However, the trick is to have a solid strength, such as the strong support from EU in sustainability, the availability of raw material, and the eco-friendly marketing campaign. This certainly will provide us several market opportunities, giving credibility and leading to a bulletproof idea. To conclude, we'd like to leave you with this quote to Lavoisier: in nature, nothing is created, nothing is lost, everything is transformed. Together, we can make a better world. We are Ecolution team. Thank you all for your attention.
Excellent. Thank you very much, Tanya.
Thank you.
We are ready for the Q&A block for you. Let me see if big members are already there in the Q&A. Not yet. Anybody in the chat? Not yet. We're formulating our questions, apparently. I see there that question was a previous one. Nobody yet. Well, I have a question for you.
Yes.
What is the feedback from actors in the field of food processing, food processing and fruit processing in Portugal with this idea, if you have had any contact with any of the actors in this field?
We are still in very early stage of our idea. We only have some academic feedback for professors, and We not yet contact any kind of industry, but the feedback we are receiving, we are trying to better our idea along the time we have in this competition. So no, we don't have anything from industry. Everything we have is very much academic. But if any one of the members want to add anything else?
Like Tanya said, we just talked with some professors, and some of those professors have a direct connection with food industries. As we don't have this direct connection, we didn't make this direct connection, but we know professors that have. So, yeah.
Okay, thank you. Let me see if there's any question from the floor. Nobody there yet. And I am sure everybody is still online. And either
we hope so.
Yes. And either I see a question coming up in the Q&A. Another one here. Let me take the second one to start with from Rob Bakers. I assume it's about collection of peach kernels at industrial facilities. What is currently happening with those kernels, this waste, if it is, right? Is there enough volume in one industrial facility to justify investments in the other technology? So go ahead, please.
If I understood correctly, currently the kernels are discarded and incinerated. So companies pay to discard this waste and exactly like I said, incinerated simply. Nothing is done with the kernels. And here in Portugal, we have a large company that is Campbell that produces juices and pulps, and they simply discard tons and tons of kernels. Nothing is done with them. Don't know if I answered all the question.
So are you saying that the quantity of these kernels, this waste at this industrial facility that you just mentioned, is that enough to start up some sort of industrial activity?
Yes, for the calculations we have made, it is. It's a very resourceful raw material. There are plenty of kernels.
Okay. Okay. And let me follow up with this question by Nuno Coelho. Why did you choose the peach kernel, specifically that one, from the fruit processing in your country?
I think it's the bigger kernel and has the large concentrations of the linoleic acid that we want. So we think it's the most appropriate for this idea.
Okay, this corresponds with a question by VJ, I hope. Have you thought about kernels from other fruits? Kernels from other fruits. Okay.
Yes. The kernel of the peach is the largest, and it's the one that has more lipids. So subsequently, it's the one that has more linoleic acid. So yeah, it's the one that it's the most viable for our idea.
It's a good point to start on.
Yes.
We should say.
Okay. Let me follow up with a question from Irina. Irina says or asks, did you perform already lab scale process to obtain CLA? And what is the yield if you did? And do you plan to perform functional analysis of your CLA?
We haven't done anything on a large scale. Everything is reported in the literature, and we are basically in the start of this. And we hope to obtain the yields we talked about in the presentation. It's everything well reported. So no, we haven't done anything physical per se.
Okay. And that will be that question in the Q&A, in the chat. I see nothing. All right. So as I understand it correctly, your project is still very much in the initial stages.
Yes.
The testing phases, I said, before you go on. Okay. But the idea itself is very clear. All right.
Thank you.
Then I would like to thank you very much for your time, your presentation, and providing the answers to the questions proposed. Thank you very much.
Thank you for the
Thank you once
opportunity.
again.
Thank you.
Thank you. Now, permit me, audience, to correct the mistake I made at the beginning by skipping Kees, but I'm sure he did not mind that much. Mr. Kees de Hooyer. Kees, can you please take the floor, and in about 2 minutes or so, can you give the audience a quick overview of the first step, the first round in this BISC-E final of 2021? Kees, please.
Sure. Thank you, Nelo. Well, I have some mixed feelings about the entire thing. One hand very sad, one hand very happy. To start with the happy, I think we did the right thing, and making it big in Europe. Let me congratulate you, Nelo, and Anastasia as well, for organizing this and having 12 countries in here. The sad part, of course, is that you were not able to see all 12 proposals, only 5. You missed a lot. You missed a lot of the bright minds of Europe. The next bosses, I always say to them, knowing that there will be no more oil digging in 20 to 30 years. So the future is the bio-based, actually. Having said that, we had great discussions, great presentations, longer than what you saw now. We had a new voting system in Excel, which we did in total transparency. I did not vote for the Dutch team, and my German colleague did not vote for the German team. And later, we agreed to add the average score of the others into our respective fields. And so we came to our top 5, which you now have seen. And that's basically within 2 minutes and all I have to say.
Thank you very much, Kees. I think the point you just brought forward is very essential for everybody and for us in BIC as well, that the voting is fair. We do not do things that would create any unfair treatment from any other team. So indeed, as you stated, and I was a witness of that, or at least I was informed in detail that there was you didn't vote for the Dutch, neither gave up for the German team. Excellent. Thank you very much. Okay, thank you, Kees. We will now proceed with the next step, which is the voting. And let me remind you all present that the voting steps, the voting procedures is as follows, and here are the steps. You have about 2 minutes, or max 2 minutes, to cast your vote. You can only vote once, and you will see as the window pops up that you cast your vote, you submit it, and it's gone. And again, I repeat that students and members of the panel of experts are not allowed to vote. Therefore, I would like to repeat to you the judging criteria that are projected here again. The expert jury used the same criteria shown here, and I'm asking you to do the same. You may look at it from a different perspective, or you would from industrial perspective, but these are the 5 things that we ask student teams to make their project, and they're shown here. The innovative aspects, please judge the proposals along these lines. The novelty, the creativity of it, the sustainability, the circularity aspects that the project could bring to us. We're very much on this, as you know, in the next 7 years. The technical visibility, can it be scaled up towards market deployment? The applicability, is there a need? Is someone in need waiting for this? Has this been tested? And is it competitive when it gets there? And the marketability, is this project marketable? Have the teams already made a convincing enough presentation to show you that this thing could work? I should say this project, this idea could indeed go work and resolve some need in the market. Therefore, having said that, if I'm not mistaken, you will be offered the opportunity to start your voting now. Marco, go ahead, please.
So I would like to thank you all for voting. And while Nelo and some other people are analyzing the results, I would like to welcome Mr. Ballesteros, Mr. Isidro Lazo Ballesteros, who is a member of the cabinet of Commissioner Gabriel, who is the Commissioner for Innovation, Research and Education. So it all comes together. I would first like to give the floor to Mr. Ballesteros before we will hand over them and announce the prize of the winners. Mr. Ballesteros, please, thank you for joining us.
Thank you. Thank you very much, Dirk, for inviting us. And thank you for organizing the Biosynergy 2021, and in particular the BISC-E competition. We in the commission, we believe that the topic of biotech innovation and startups is crucial for the future of Europe from a health perspective, but also from a business perspective. I would like to start by apologizing and excusing on behalf of Commissioner Maria Gabriel, who could not make it here, despite all, you all know, her strong support for startups and innovation, and in particular in the area of biotech in the last, since her mandate, but certainly COVID has put biotech at the top of the political interest, and at the top also of I would say also the investors. And I will say, as we'll start now by giving some data, some very positive data on how this biotech sector has been evolving. The data we have is from 2020, and so the heart we were strongly hit by the pandemic at that moment. And despite that, the biotech sector, biotech startups, they grew exponentially. And they saw, in terms of initial public offerings, IPOs, they saw a record of $9.7 billion into the cash in by the biotech startups. And the VC funding, the venture capital funding, the risk capital funding, grew in Europe at 45%. This is still lower than in the US, but we grew at twice the rate that the investment in the US. So I think these are all very positive news. We are seeing, as I said, this VC's awakening of the opportunities in Europe. Certainly the case of BioNTech success was a very important one. But at the same time, the success of BioNTech also puts or highlights a deficit that we have in Europe. And I'm referring here to the ecosystem, to the innovation ecosystem. And this is always the approach of Commissioner Gabriel. It's not so much talking about separated parts of the puzzle, so taxation or investments or talent, but talking as a whole on what the Commissioner Gabriel is talking on the European innovation ecosystem. So we need to ensure that when we have talent people like the one participating in today's competition, they have the support to be able to, in terms of capital, to start growing the company, growing the startup. Later, they need the support to have the right access to talent, to be able to continue growing. And later, they also need the support of the industry to be able to work with them closely. And this is, as I said, the BioNTech case highlights a positive things. We are able to create good startups in Europe, and also highlights the deficit that we need the European startups working more with the European pharma or biotech industry, large industries, and we have many. So it's not a lack of that. Nothing against BioNTech working with Pfizer, but clearly this is signaling that having so many European big companies like Pfizer in Europe, this is certainly highlighting. And this would be the case, an isolated case. We say, okay, I mean the founders decided to work with Pfizer, the American company, is fine. It is free to do it, but unfortunately, this is what happens in most of the cases, as you well know. No, so it's a systemic problem that we have here on the lack of industry working with the startups, and that can only be solved at the ecosystem level. No, so we define the ecosystem in two different ways. The most catchy way for me is what the people themselves, people like you say, that is founders helping other founders. So that's an ecosystem, and that is a very good definition. From a more bureaucratic, if you want, definition is all the different players from university to founders, of course, entrepreneurs, to investors, to policymakers as well, to accelerators, they all working together. That's how we define the ecosystem. But also the other one, founders helping other founders, is also an excellent definition, because it's all about that. It's about collaboration, cooperation about the players who are in the area, in this case of biotech innovation. So allow me to conclude, because my time is short, but I would like just to give a glance of the supporting mechanisms of the Commission to reach this objective of the pan-European innovation ecosystem that the Commissioner Gabriel is always advocating for. So we have essentially 3 programs, and then a 4th one. The 3 programs who are specifically dedicated to this are the European Institute of Innovation and Technology, that with a budget of 3 billion euros is building ecosystems around universities. And here we have the EIT Health as the case, very important case. And within the EIT Health, I would like to highlight the Venture of Excellence, the Center of Venture Excellence, with almost 2 billion euros between the EIT Health and the EIF, the European Investment Fund. These 1.7 billion are for you, for biotech companies. So please look for it, Google for it, and apply for the money, because it's precisely for companies like you. So this is on one hand the EIT and the EIT Health in particular. Then we have the European Innovation Council, that is for this deep tech type of startups in the area, of course, of health as well, with a billion of 10.5 billion euros, is giving money, essentially giving funding, but most of the money will be to the startups, will be in the form of equity. So we will be patient investors. So patient investors means that we are not in a hurry to cash in and to force the entrepreneur to make an exit and selling the public offering or whatever. We will be able to stay there. And also, all the beneficiaries of the EIC, they have to have a private investor. Some of them come with a private investor before applying, but others not. And those who don't have it, we have until now always been able to find another private investor. So if you are asking for 15 million euros from the European Innovation Council, you can get 30 at the end, 15 from the public and 15 from the private. And most importantly, you might get an investor specialized on biotech, and that could be essential for you to have access to the different markets across Europe, to use his connections to have access to the big industries and other investors, etc. So that's the second program. And the third program is about the European Innovation Ecosystems Program, that will essentially develop the ecosystem. So we'll make the people working together. We will make all the players interacting and helping one another, the founders helping founders, but also all the others who are relevant players helping also always the founders always at the center. And I set a 4th program because although it's not dedicated exclusively or primarily to innovation, it might be used for that as well. But the decision is in the hands of the regions. I'm referring to the cohesion funds, to the regional development funds, or the rural development funds. We know many cases, in particular biotech startups, who are located, the founders, in rural areas, no? And for them, maybe it's easier to grow the company there, no? So these funds, these cohesion funds, it could also be used for these purposes of creating the ecosystem and supporting the ecosystem. But always remember, the public money should never be your interest, should be always getting what is called smart money. So money from private investors, private investors who are specialized in your area, so in cancer, in virus, in vaccines, whatever, because these investors has a portfolio of companies like you and connections that they have been able to get from these other startups in the last 10 or 20 years with all the industry, all the possible first customers of your solutions. So look always for that. And don't forget that we are here in the Commission to help you, as I said, mainly at the ecosystem level with the European Institute of Technology and the European Innovation Ecosystem Program, but also at the funding level, as I mentioned, with the IT Health Center of Excellence Venture, and also the EIC. So with this, I'm happy now to give the floor to my colleagues to announce the winners for the ceremony of the winners award ceremony. Thank you for your attention.
Thank you, Mr. Ballesteros, for your kind words and interesting messages. I think there's also another, instrument also important to match indeed the public funding with the private, I would say, funding, and these are the public-private partnerships that will be started probably soon. I think there's an agreement, Commission, the member states, and I think several of these partnerships are also linked to our activities. And you have the innovative health, of course, but in our case also, I would say the circular bio-based economy, you know, the CBE is very important. So I think also the partnership is really an instrument to match, I would say, public funding and private funding to stimulate deployment, especially in the area also that we have showed this morning. I think we are still doing the final counting because we have to match the, I would say, the results of the jury, the experts, with the results of the voting. And I was informed that we will soon have the results and that we can announce the results so that you can virtually hand over, unfortunately, virtually hand over the prizes to the winners. So let's see if Nelo is available. Just on time. Thank you.
I'm available. And thank you. I heard your presentation, Mr. Ballesteros, a little bit with my right eye because I was doing the calculation with the jury chairman, Mr. De Gooijer, but we're there. So thank you also from my side. Good. We have a result and agreed with the jury chairman. It's obvious, it's a very clear result, so there's no doubt about it. There was no intervention, no discussion. So we have the result, and I just shared it with my team. I would like to see if the team is ready. I'm waiting for a sign from Marco or from Ben. And this is, of course, the moment, this suspension by all of you, including us. Well, maybe not me, because I know the result. This is unfair, the statement, I know, but I'm still waiting for any slide to be put up. Either the one that shows that we're crunching the numbers, even though that's finished. Just a second, we are obviously can you, Marco, put up the slide instead of this ugly empty screen? Put up this very nice slide again, and we're crunching the numbers. The crunching has been done, but now we're transferring the correct data to the information that we will be showing you up now. And we would just like to make sure that we present the right results, the right number, 3, 2, 1. Either we have a short disruption again with the service company assisting us. I hope not, but he should be coming up soon. But let me tell you what's going to happen. We're going to show first the, okay, here's the vote, the slide that I was asking for. You know, this is a very, look at this. So we will be presenting or revealing first the third prize winner. And then you, Mr. Ballesteros, can, okay, he's ready. You can make your the presentation to the winner of that prize. Are we ready? Just a sec. I need to confirm here with that we are 100% with the results, just to make sure we don't want to have any mistakes. And I just confirm that the information is correct now in the hands of everybody in the background. So if the firm is ready, if Marco, are you ready, then let's announce the winner of the third prize. In the third position will be, or is, or has ended, the team of, here we go, the team of Belgium with a project Loaf Foam. You remember taking waste of bread, and the score of the total combined scores is by the team of Belgium is 22%, and here is a winner for the €1,000. Mr. Ballesteros, if you would say a few words and offer the check. If I'm not mistaken, the check will go on now also, right?
Thank you. Yeah, congratulations to the team from Belgium. I suppose we will see now then. I think they are the ones who should be talking now and thanking and I take advantage of this. Take advantage not maybe about the money, yeah, very good, but mainly also about the visibility that you will get with this. This is extremely important for you. I see you now. So congratulations to you and to all your team here from the neighboring. I mean, in Brussels, I don't know where you are, but congratulations.
Thank you.
Excellent. Thank you, Mr. Ballesteros, for this. Thank you, and proficiat, I can say in Dutch, right?
Dank u wel.
Gefeliciteerd. Then let's move on to the second prize winner, and that is Ireland. Team from Ireland with this nice project on the towel to subtract components from wastewater. The score of this team, the combined score again, the jury and BIC, is 26% of the voting, and the winner of a nice check of 2,500. Mr. Ballesteros, over again to you, to this team.
Okay, thank you again, and thank you to the people from Ireland who has been able to get the second prize, Phyto Towel. And I mentioned before, the value is not on the money; it's on the visibility, the recognition, the credibility you are going to get with this. I hope this will open you the doors of investors and also the companies, the industry, the biotech industry that are the ones organizing this. So this is certainly going to give you a lot of visibility on this in this industry. Please take advantage of that.
Thank you very much. We're really, really happy. Thanks.
Thank you. Congratulations in Ireland, Laura and the team. And again, thank you for these words, Mr. Ballesteros. And there's one to go for you, Mr. Ballesteros, and this is the top prize, because at this moment, the winner of the BISC-E 2021 is, here we go, the Netherlands. The Dutch team with the project Water Skins has collected 30% of all the votes of the combined jury and BIC, and therefore the undisputed winner of this year's competition. And I would like, Mr. Ballesteros, the floor is again to you.
Okay, well, thank you. It's all here in very neighbor to where I am in Brussels. So it's again, congratulations to you, Water Skins. I think this will get a lot of media attention for all, but certainly for the winner. So again, start working on that. I have got testimonial from some winners on another award ceremony where they have participated, that they can see immediately the rise of, at that time was phone calls, like 6-7 years ago. Now I suppose will be the tweets, followers, or emails, etc. So this will be the first indication that you are being noticed. And again, take seriously the next couple of months to use this to have access to all the whole ecosystem, industry, investors, university, of course, and all the different players, so that you can become one of our future biotech unicorns. Congratulations.
Excellent. Very appropriate words, Mr. Ballesteros. Muchas gracias. Okay. And now, the floor is to the winners. Mag ik, Gijs, Maaike, and Casper We kunnen even Nederlands praten, but let me switch back to Dutch, or to English, I'm sorry. Can you give us a quick first reaction and also react to the words of Mr. Ballesteros?
Yeah, wow. We are just super happy to hear the result. We want to thank everyone who voted for us, and of course also thank the organizing team of BISC-E. It was great to have this opportunity, and we hope that the exposure that the competition gives us can help us set up the project further. We are super humbled by the result. We also want to give our compliments to the other teams. We thought we saw some really interesting projects today, and we will follow them with great interest. Also, we would like to thank Mark van Loosdrecht, Yumai Lin, and Stephen Picken, who helped us guide at the beginning of the project and throughout the project, and also made sure we had lab access at the TU Delft, which helped us to develop our prototype. And yeah, I would just like to thank you again and wish you all a very nice day.
Thank you. I saw Gijs going like this and everybody else, and that's the reaction we would love to see. So thank you very much. And be aware, aside from this very nice €5,000 prize, you will get, as a group, as a company, as a startup, whatever, a 1-year complimentary membership of BIC as a full member. You can witness and participate in all the programming. We will bring you to our networks. This is also bring in contact with the several functions in the European Commission that we work with to develop programs, etc. So you will be in touch with the industry and through us with the government, and we will give publicity. You will be world famous. All right. So thank you very, very much. And thank you again, Mr. Ballesteros, for your participation and handing out the prize. Thank you very much.
Thank you. Bye-bye. Have a nice day.
Thank you. Now, moving on, before we close this part, what are the next steps for BISC-E? We will proceed towards our objective to make this event the event for students across Europe in the fields of bio-based innovations and good ideas. And for next year, we're aiming at least 20% of national winning teams to participate. And we will involve in this process all members of BIC, the industry members, but also the non-industry members, the universities, etc. We call them associate members. The BIC education team, which I will revive as of January, the 2 advisory bodies of the joint undertaking with the Commission, the States Representatives Group, and the Scientific Committee. And as the numbers will grow up, we will probably end up in having several steps before we arrive at the 5 teams in the final round. So be aware of this, and the winning team, the Dutch team, will be invited to assist us in this process and take over from Anastasia of the Citrion team in Greece last year, who've done an excellent job. Thank you also for this, Anastasia. Now, this marks the end of the public part of the big event by Synergize, and I hand over the floor to Dirk. Thank you.